All right. For this section of notes, we're not working out of the book. We're working on guided notes for various things of a circle. So, the last topic and module that we're going to be getting into in pre-algebra, we're almost at it, is working with volume. So, volume is the amount of space that an object can be filled up with or takes up. And that'll be volume of a cylinder, a sphere, and a cone. And you may notice that for those objects, they all have some type of circle inside of it, like a circle inside of a sphere, a circle in a cylinder, a circle in a cone. So the thing is, we have to kind of build up our background understanding of what is a circle or how to find different parts of a circle. So what is a circle? It is the set of all points equidistant to a point. So what do you mean by this? This isn't a perfect circle, but just imagine it is, right? This is what we call as our center. Center of the circle. And what it's saying is all these points that are on the edge of the circle are equidistant, meaning equal distance. So like this point and this point is the same distance as the center to this point, or as the center to this point. Okay, it's a set of all points that are equidistant. Now, what are these other parts that are on the circle? This line right here from the center to the edge, this is called the radius. So a radius is what we call is a chord. It's just any type of line in a circle, but it goes from the center to the edge of the circle. A line that goes from, I'm going to highlight this to provide emphasis. A line that goes from edge to edge but through the center is called the diameter. You can write it any way you want. And then on the exterior of the circle, the edge of it, you can see the vocabulary term on here. This is the circumference. And the way you want to think of the circumference is like for closed figures, it's the perimeter. So it's the outside, or, for your house or apartment. It's the boundary of it. So it could be like a fence. So maybe think of this as the fence of this like circular park. We just call that circumference. It's another word for perimeter buffer circles. Okay. Now, we're going to be finding the circumference and the area of of a circle. But I want to derive the formula. So with these notes are only front side. We're going to be going to the back side. The back side, there's nothing on it, but we're just going to be writing some stuff on it. So what is the circumference? Circumference is the distance around a circle. Right, I try to put it as simple as I could. So this blue region here. Okay. Now we're saying that the formula is two things. That C is the circumference, and the circumference is equal to 2 times pi and times r. So what do those things represent? Right? Pi we know as approximately 3.14, and r is, in this case, it's the radius. I'm gonna highlight this. But another thing is that you could also use this formula. I don't use this formula as much, but you could rewrite this as pi d, and d is the diameter. And why are these two things the same? The reason, I'm going to highlight this in a different color. You can circle this if you like. Because if you have two radius, that pronounced as a plural is called just radii, two radii. Is one diameter, because you can think this as this. This is a radius right here. This is a radius right here. And a radius plus a radius is the diameter right there. So we still have pi, but the only thing that changes that 2r is the diameter. But I want to go over why is this the formula. So I'd like for you to we don't have enough room on the front. We just have an example to find the circumference. Let's go to the back. And if you can you draw a vertical line to kind of create our guided notes? So y is the circumference. Circumference 2 pi r. Okay. Now, with this, normally in previous years, I would have used like a string and would measure it, but we're just going to try to do our best that we can. So I'd like for you to draw um, a dot, and I'd like for you to draw a circle around the dot where that dot is like the center of the circle. I might not do a good job of this, but let's see what we can do. Oof. Okay, I'm gonna redo that. This might take a couple of tries. My goodness. Okay, this is not good. All right, we're just gonna go with this one. That is not good, but we'll take it. What I'd like for you to do with this circle is I'd like for you to draw kind of a flat line that goes through the center. Kind of looks like a Pokeball. And we're just gonna call this R's. So I'd like for you to really highlight this right side from the center to the edge, this radius here. And what we're going to do is wrap R around the circle. And there's gonna be something that we notice. Okay, we're gonna start right here. Now you can use your fingers, and you can't see me using my fingers, but I'm gonna try to put tick marks throughout the circle. So if I take that radius and I try to wrap it around, let's say if I wrap it around from this point here, maybe it reaches like over here. Maybe that distance right here, we're gonna say this is 1 radius. Okay, I'd like for you to draw this. I'm gonna put a different color though. Let's put red. Okay, and if we wrap it again, maybe you get right here. All right, maybe that's probably not to scale, but we're just gonna put another R. And then if you wrap it another time, you're gonna see this, another R. And then we have this right here. All right. So we have this little extra bit. We're just gonna say this is extra. Okay. Now what's in red is I want you to consider, right, we have 3 R's here and a little bit. I want you to think of what number represents 3 and a little bit. Okay, 3 and a little bit, I'm gonna use a different color. Let's use blue. That means this entire thing, this northern hemisphere is 3 and a little bit. But the number that we know that represents 3 and a bit, it is pi. We can write it like that, or sometimes I'll write it like, just like a kind of a tabletop here. It's pi. So it turns out that with any circle, if you take the radius and try to wrap it around the circle, it'll go through halfway of the circumference, pi times. And then that means that this part as well, I'm gonna draw an arc. I'm gonna draw another arc. We'll put pi right here again. So this is 1 pi, and this is 2 pi. So why is the formula, right, 2 pi r? Is because, right, this for the circumference, it wraps around, right, 2 pi times, and this is of the radius. So, right, if you take any radius of any circle, you're welcome to like draw a circle and use string or use like maybe headphones, wire headphones, like, and just kind of compare how many times it goes around. You'll always find that it will go around halfway, 3 and a bit, and then the other 3 and a bit, making it 2 pi. Okay, so that's why the formula is this. Now this isn't the major thing. This is something you should have learned in Math 7, but let's now apply this. Right, you don't actually have to understand like where the formula is derived from. I wanted to make sure that you have some type of understanding of like this Pokeball looking figure, but right, just in case you are curious where this is coming from, that's where it is. Okay, but what is important is if we know how to apply it. So example 1, find the circumference of this circle. We're saying that the radius is 5 inches. Okay, so if this is 5 inches, well, how much is this entire, right, boundary of the circle? right? Would it be more than 5 inches? I would assume so. Okay, so let's use our formula. We're going to rewrite c equal to 2 pi r, and we're going to plug in what we know. For circles, pretty much all you need to know is what the radius is. Find the radius. So we're going to say find r. And we know that r is from the center to the edge of the circle, so it's 5. So r is equal to 5. Let's plug 5 into r into this formula. So we're going to have c equal to 2 pi, and then I'm going to put 5 in parentheses. Okay. Now at this step, we can multiply 2 times pi and then whatever that is by 5. But what I prefer to do is we can, since this is all being multiplied, we can use the commutative property and just put these together. Instead of putting them together, I'm just going to multiply them together. Let's multiply 2 times 5, which is 10. And typically when you write your answer in terms of pi, sometimes in SBAC, you'll actually see the answer as 10 pi. Or if they tell you to multiply, they'll say use that pi is approximately 3.14. Okay, so let's go to put 10 times 3.14. And multiplying with 10, we should probably know with scientific notation, it's not too bad. We just have to do something with the decimal point. But in case you're not sure, let's use a calculator for this to prove it. 3.14 times 10. Okay. Let's take our calculator. Let's clear this out. So 10 times 3.14, enter. It is 31.4. Okay. So the C is equal to 31.4. Pretty much what we just did here is that we just moved the decimal 1 point over. All right, so it's 3.14, but what? It's going to be especially important that we know the units for this topic. And it's 3.4, we had our units in terms of inches, so IN. So 31.4 inches, that's about waist high, or a little bit lower than waist high. Okay, great. So that is for circumference. The big thing that I really want to focus on though is area. Area is going to be really important. We're going to be using this formula pretty much until the end of the school year. So we have to become familiar with this. So the area, what does the area represent? It is the space inside of a circle. So you know how we outlined this circle in red? In this case, the space inside of the circles, we're looking at this. We want to figure out if the circumference is the fence around some type of figure, the area is how much paint I need to use to fill up this circle, right? Now, something that we need to understand is for area, right, we can see that the diameter is 20 feet. The area represents, it wouldn't just be in terms of feet, right? Because an area represents a 2 by 2 dimension. So let's say like the area is equal to base times height. You use this for rectangles, right? And let's say it's 1 foot by 1 foot. So we would say that this, well, let's just actually put 1 foot by 1 foot. If you multiply 1 times 1, right, it's also 1. But, so that doesn't change. But what does change is that you multiplied a foot times a foot. So this is 1 foot squared, or we would say this as 1 square foot. Your answer needs to be in terms of this or this, because this tells us how much paint that we need in order to fill up this circle, right? This is 1 square foot, right? We're saying that the diameter is 20 feet, but how many square feet needs to fill this up? Okay, and this definitely isn't drawn to scale. I drew too big. Okay, before we get to this example though, I want to derive it one more time. Why is this formula here? Yeah, I guess I'll put this in blue. The area is equal to, we have some common symbols, pi r squared. So we square the radius, multiply by itself, and then whatever that is, multiply by multiply by pi. So what I'd like for you to do, again, let's go to the back side. We're gonna say y is the area, pi r squared. Okay, I'd like for you to draw a circle. All right, I'm just gonna keep that terrible circle. I'm gonna put a center, and I'd like for you to make this a pizza. We're gonna cut this in a bunch of slices. So I'll go like this. You can cut it up in how many pieces that you want. But one thing I want you to do though, is I want you to highlight the edge of it, the circular part of it. Okay. Now, what happens here is that we're going to arrange these pieces of the pizza in this way. Okay. I'd like for you to make an arc. We're gonna put a point, and we're gonna connect the edges of this arc like this. This is one slice. And what I'd like for you to do is now we're gonna put another slice, but we're gonna organize it like this. We'll put an arc like that. So it kind of is like touching on one side. We'll keep this going. And I'm gonna keep going until we have like 8 pieces all connected. This is 4. You're welcome to pause at this point if I'm going a little too fast. Okay. Now, there's a question here. Actually, let me highlight this. I'm gonna highlight this in blue. Now, it doesn't seem like it, but if you were to cut it up in more pieces, you would get a clearer vision of this, of what shape is formed. I'm just gonna say what shape. If I look really, really far away, maybe take my glasses off, there's the kind of shape that's kind of formed here. It's kind of a rectangle. Okay, and the area of a rectangle is base times height. Okay, now, again, this isn't quite to scale. This looks like some teeth, but roughly this is exactly it. Now, we need to figure out what is the height of this. Now, the height of this, if you think of this as what I drew here, this is all the radius. So the height of this entire figure is about this. Now, we can't really use the diagonal height, but if we were to cut this in more pieces, it would be more perpendicular. We're gonna say that the height of this, instead of H, I'm gonna put an R. And then the base is what's in blue, as you can see here. I know that it's arced, but we're gonna make some assumptions here. Well, what's in blue here is the circumference, right? 2 pi r. But you may notice that from here to here, this is only half of the blue stuff, right? The other half is right here. So the width of this, or the base of this, is whatever half of this is. So 2 pi r divided by 2. And this is kind of nice because this cancels out. So we're seeing that the base of this is just pi times r. So I'm going to plug this in for b for the base. I'm going to put this in parentheses, pi times r. And with this formula, this is how we derive the area of a circle. It is pi. I'm going to drop the parentheses. But r times r gives us r squared. Okay. So again, just like with circumference, maybe not super essential that you know how to derive the formula, but I just want you to understand where is this formula coming from, so that, right, it's not just totally out of the blue. But this is a standard in Math 7, so maybe this should be familiar from last year. So now let's go ahead and apply this. That's the important part. Okay, not that you know how to derive it. So let's rewrite the formula here. Pi equal to radius r squared. Oh, sorry, pi radius squared. Okay, we're gonna put a equal to. Now, if you see a problem like this tells you, and it has a total connection from end to end, that this is 20. This does not give us the radius. This gives us the diameter. So we cannot plug in 20. But we can figure out what is half of it. Half of 20 is 10 feet. Okay. So I'm gonna plug in pi. We'll put 10 feet. Oops, it's been on the outside. And when we simplify this, we're going to simplify what's inside the parentheses. Right? Remember, when you don't have something that has a written exponent, it technically has an exponent of 1. I'll put a 1 even with the feet as well. 2 times this 1 is a 2, so this is 10 squared. And 2 times 1 is feet squared. This is where I get this this unit. 1 square feet, just like what we have here. Just think of it as like literally a square where it's 1 by 1 foot. Okay, now I got to simplify some things. 10 squared, 10 times 10 is 100. So this is 100. I'm gonna put that in front. We're gonna put pi right behind it, and this is feet squared. Normally, I'll just call this as square feet. I'll switch the 2 with the FT. And that would be your final answer if you were to write this in terms of pi. So I'm gonna put this as one viable answer, but I'm gonna put this as or. What you could also do is multiply by 3.14. And multiplying 100 times 3.14, we can do something with the decimal here again, but let's go and show on the calculator to prove it. 100 times 3.14, it's 314. So the area of this is 314 feet squared or square feet. So if you think about it as like, maybe this is a 1 foot by 1 foot, we would need 314 of these hypothetically to fill up with this in terms of paint. So that would be our answer. Okay. All right, so we're gonna leave it at that. We'll get to some practice, but let me know if you have any questions.